Okay, we'll move on to projection of cones. So projection of cones is similar to pyramids. So whereas in pyramids you're going to have the base edges and corners, whereas in this you will not be having any corners or edges. Instead it can rest only on a point on a circumference of its base. There will be edge or the corner as you study in case of projection of pyramids. Can have a simple problem something like this. A cone of base diameter 60 mm and a height of 80 mm is resting on one of its resting on a point on a circumference such that the axis is inclined at 30 degrees to HP and 45 degrees to VP. That's the very simple problem. So in that case it says a cone of 60 mm diameter and a height of 80 mm is resting on a point on its circumference. A point on its circumference such that the axis is inclined at 30 degrees to HP, so we're going to keep the lamina. So it says axis is inclined at 30 degrees to HP, so this will be the position. Then it says you have to, keeping the inclination with HP constant, you have to give the inclination to VP. So and again you have to see whether that length is inapparent. Based on that you have to go for finding beta in this case. If you don't find that, 3 words. So in this case it says as a cone of 50 mm diameter or 60 mm diameter and a height of say 80 mm. So in this case you're going to have the base and now a circular profile, and this in case of pyramids you're going to call it as apex, whereas in this case they call it as vortex. So vortex, this is vortex, this is the base, it's a circular circle, and that it can rest on any point, okay, on its circumference on HP. In that case you can start like this. So I'm going to have the axis. So again in this case you have to divide the circumference into 12 number of divisions. So dividing, when I say dividing, this is nothing but getting points, equidistance points on the circumference. So just getting the points. This lines what I am drawing now is not important, okay. So then you're going to have this as A, B, C, D, E, F, G, H, I, J, K and L. So in that case if you project, this will be A dash, so O, O1. So O is the vertex, whereas O1 will be the center of the circle and the base. So this is, so K and C will be in the same line, whereas this J and D will be in the same line, this I and E will be in the same line, G and H will be F and what do you call this, H will be in the same line, okay, whereas this is say the G, right, okay, so this is G. So in that case you're going to have this as B, this as C, this is D, this is E, this is F, and this is G, H, I, J, K and L, which are on the other side, with all these in with the dashes because all these are front views, and we're going to have our dash. So now this is the pyramid, cone. So looking like angle in the front view. So when you look at like this in the front, whereas in the top you can see like a circle. There will not be any edges, only imaginary edges. Then you can say this is nothing but the generators. Okay, so this solid can be imagined something like this. So we're going to have a line, okay, rotating about a circle with a fixed one end. Okay, so the path traced by that point, okay, the path traced by this line when it is rotated about this, along the other end when it is rotating about the circle. Okay, so this is fixed and this is the rotating about the circle, and the path traced by the surface that is traced by that line, inclined line. So that line, what you call it as generator. In that case you can imagine many generators which are here on the surface. So these are called as end generators, and this is the axis. So this is vertex and this is the base. So it says the axis is inclined at 30 degrees to HP. In that case even they can give the base. So they can give you the base as 60, then automatically axis will be at inclined at 30 degrees. So they can give you even the base for one angle, and they say axis is inclined in the for the other inclination. So even in that case, so transfer all this, so redraw the sketch, right? In this case I'll go for redrawing the base. Then I know what is this height is 80 mm, then I can complete this triangle. Or taking this length, I can just go for constructing this triangle, redrawing this triangle. So then I'll transfer all the distances from here to here, A to B, so A to C the same, okay. A to C, then this is D, then this is C, F, G, right? A, B, C, D, E, F, G, H, I, J, K and L. So because these are on the other side when you're looking in the front, and that will be in the bracket, and all these will be dashes, O dash, and this is O1 dash. So I can project this now. Then all the points, if I project here and draw the locus from all these points, okay, so because there are many points, I want you to try them, okay. So this, same I can go for this. If this is A, then this will be for the B, and then this is for C, and this is for D, and this is for E, this is for F, and anyway this is O. Then this will be the A, this is B, this is C, and this is D, this is E, this is F, this is G, right? Okay, this is H, this is I, this is J, this is K, and this is L. So L and L in that we can. So now when you are looking from this, from the top, to get the top view, so see the base you cannot see. In that case you can check out here, the vertex is nearer to you compared to the other end of the axis at the base. So you cannot see the base completely. In that case you go for drawing them with a very thin line. So because you are going to have visible and invisible surface here, so just let it be very thin when you draw. Don't draw that. Okay, so because here now only the outermost curve should be made dark, so complete that with a thick line, a continuous thick line to this. See, so anyway I'm going to get this. Then from this point tangential to this outermost curve, so tangential to this outermost curve you have to go for drawing the line. That's why let it be very thin when you draw. Then after that just go for drawing this outermost curve. From this you have to draw a tangent, then that becomes the outermost generator. So again here you can go for drawing that outermost generator. So when you draw, let it be very thin, then you can go for making only this as a dotted line. Join this curve with a dotted line. So then this the O1 only up to this. So anyway you can see this completely because there is no edges here, no overlapping. You can go for drawing using this with a pencil. H pencil a medium thickness, whereas here you can see this is the outermost curve and this is the boundary. Outermost boundary I mark with a dotted line because you cannot see the complete base, so there will be some surface of the base invisible that I am going to join with that curve with a dotted line. So in this case the axis with HP can be given in many ways. The first thing is they may say directly axis is inclined. The second case they may say the base is inclined with HP, all this with HP, right? Okay, second one will be inclination with VP only. Base is inclined with, right, okay, HP. Or the third they can give you is diameter passing through the point on the circumference which it rests. Point on the circumference passing through the point on the circumference which it rests, okay, and which it rests. So in this case, see, the base inclination can be given or the axis inclination, both will be actually at 90 minus that angles, okay. So they can directly give you as the base is inclined at 30 degrees to HP and the axis is inclined at 45 degrees, or they can say the axis is inclined at 30 degrees to HP, then they say and 45 degrees to VP. So in this case they can say base is inclined at some degrees with HP. In that case you can go for incline the base or the axis depending upon that. Of the diameter passing through the point on the circumference on which it rests. So this is the point on which it is resting, so that is G. So the diameter passing through the point is nothing but GA. So GA, see, GA will be the diameter passing through this point G where it will going to rest, on which I am resting this. In that case, when the base you incline is nothing but that diameter passing through that point is inclined. So anything can be given in that way, they can give you. Or sometimes he says to give the inclination, he says is resting on one of its points on the circumference such that the vertex is, sometimes they say vertex is vertical. So this, no, the vertex are not vertex is vertical, but the generator passing through the point is vertical. Sorry. So generator passing through the point, okay, end generator is vertical. Even in that case the axis will incline, even the base will incline even then. Or they can say that the vertex is some distance above HP, so they can give you this distance. Even in that case previously it is at say 80 mm axis height, means it will be at 80. So if you give that to 60, then you have to rotate by drawing a line at 60 degrees, taking this length, axis length, okay. So there are, you take this length, okay, so this end generator GO, then you can cut. So then the axis, see, this O will be at 60 mm above the ground, okay. So see, so many times, so in any cases you can get. Now the fourth point is the vertex height can be given. For first inclination they can change in this way, or they can say that one of its end generator is inclined is perpendicular to HP. So end generator is perpendicular, right, okay. So perpendicular to HP. So in 5 different ways they can give you to draw this first set of view. The second inclination will be the axis inclination. They may say in one more condition, I'll tell you that, okay. So for all these, so based on this inclination what I has given, you can go for drawing this view, you can get this. Then in this case, if they say the axis is inclined to VP, along with this, if they say and axis is inclined to VP, since the axis is inclined to HP here, the projection of this, in all these cases the axis will going to incline with HP. Even in this case, when that, the end generator becomes perpendicular to XY line, okay, so the axis will incline, then the projector of that on HP, the top view, So that will be apparent length. Then if they say simply the axis inclination with VP, then you have to go for finding beta. So that beta inclination you have to redraw that. Then if they say 45 degrees, go for drawing the 45 degrees, then taking the true length on this. So then drawing the locus, then taking this apparent length. So true length will be here, right? Okay, so true length will be here. Okay, so taking apparent length, you have to cut that. Okay, so actually this is the true length of say 80. Somewhere if I'll take that length. Okay, so true length, then taking the apparent length, I'll just cut this. So then this becomes your new inclination. So that is your beta. So this is the phi what he has given, inclination with HB. So then now the axis will be inclined in this position, so you have to redraw now this view in this inclination. So taking, say if this, you take this as O, I know this is from O to O1, this length, you can take that as O1, then extending that, I can just go for inscribing this now, because you're going to have many points, better to inscribe in a rectangle. So 1 2 3 4. So then at O we're going to have this perpendicular to this line will be your 1 2 3 4, right? Okay, 1 2, then go for drawing that. So from O, check out what is that point A is lying at that point. You can just go for completing this rectangle. So this is your A. So construct the grid. So drawing, transferring all these lengths. Okay, 1 2 to get this B, right? Okay, so this is your B, this is your C. So then this is the length. Okay, so the length here, parallel lines. So this length you can just draw that, construct the complete grid there. Okay, so then drawing this grid again, and this you can go for selecting all the points A B C D E F. Anyway, you have done this for all, even for, so redraw this now. Okay, so anyway, redrawing this view in this position, that you know how to draw that. Okay, so anyway, we have drawn in many positions. So this will be a dotted line, then joining this. So this is A B C D E F G H I J K and L. So then when you project, right? Okay, so you'll project all the points. So anyway, this projecting, when you project all the points, because many points here, so go for projecting all these points. So G in this is your, so I, this is A, see, A, O1, G, B, F, C, okay, E, and this is D, right? So this is O, and all these points again you should project. Okay, so anyway, many points, I'm not going to draw the next view. I want you to go through that. So check out. So then locating A and A in the order if you want to go for that. So this is A, B and B. So this is B, C and C. This is, sorry, this is B, right? Okay, this is B dash, A dash, B dash. So C and C. This is C dash, D and D. This is D dash, E and E, E dash, F and F. This is F dash. So this is okay, F dash, F dash. This is F dash, and this is okay, G dash, H dash. I dash, this is H dash, I dash. So locate all the points, we'll see. So J and what is J? This is J, this is J dash, K dash, L dash. Okay, so anyway like this. So then when you project O on O, so this is O dash. So O1 and O1 somewhere here, that will be O dash. See, in this case the base is nearer to you, so then you can go for see getting all the point now here. So since the base is near to the observer compared to the vertex, so all the complete the profile of the base is visible then, so then you go for completing that with a thick continuous line. So then this is your vertex, then tangential to the outermost curve, not to any particular point, just go for drawing tangential to the outermost curve. So then that will give you the final view. See, not to any particular point, just keep your minute after like this. Okay, with the scale and go to the outermost curve. Okay, so outermost line. See, taking this to your outermost, wherever it goes tangential to that line, tangents to that curve will be a dotted line. So now this is your the solution for this problem. So if they mention instead of having all this content with the axis inclined at 45 degrees to VP, if they say appears to be inclined at 45, then you need not go for finding beta. So you know all the three sentences. Or the top of the axis is inclined, the plane containing that axis and one of the generator, okay, so that is inclined. In that case, if they say the three sentence, you need not go for finding beta. At this inclination only, you're going to redraw and will project same procedure, will get the view, right? Okay. So this is first type of problem, okay. So where it I covered actually 5 different problems by giving 5 different lines and using beta, without beta, other sentences. I hope you understood. If you have any doubt, you post me, okay. Any problem that is in the exercise, okay, I'll solve it for you if you have any doubt, okay. Then in the second type of problem, what you can expect in this will be resting on one of its end generators on HP, something like in the pyramid resting on one of its inclined edges on HP. So you cannot directly draw in VP like in case of the prisms and cylinders, whereas in this case you have to go for 3 steps method. Whereas in prisms and cylinders you can complete within 2 set of views by drawing directly in VP, getting that, then incline the axis. In that case there will not be any beta for that, okay, so only the axis inclination will be given. Even in this problem, okay, so if they say that at cone of 60 mm diameter and height of 80 mm is resting on one of its end generators on HP and the axis is inclined at 30 degrees to BP, draw its projections. So it says it's resting on one of its generators on HP. So this position, this. So in the front view you can see like this, then resting on this XY line, right? Okay. So on one of its generator. So this is the one. So it's corresponding position. When it's resting on its base, that's your first position. So resting on base on HP. So this is HP. The top view when you're looking here on HP. So this top one, when it is when looking at the vertical plane, it looks like this. So then this will be the HP, right? Okay. So then completely resting on one of its one generator. So this is the position. Then the axis inclination. We'll check out whether you have to go for finding beta for this problem or not, okay. So that's what, okay. So whenever you find, say, that length in the second set of view, when you make that end generator rest on HP, if that becomes apparent, then you have to go for finding beta. If you don't find that 3 words, if otherwise you have to find beta, so then you need not. So if you find the 3 words, you need not take beta. So this is the vertex, O1 is the axis. So I'm not going to take the 12 points, but I want you to draw them all the problems with 12 points, because getting the profile will be very difficult if you take less number of points. The more the number, so more easy will be the curve, okay. So in this case, if more the number, the more easy will be the curve. I cannot join actually the curve, I can join in any position, right? Okay, so if I have a point here, I can go for drawing again in different positions. See, drawing like this the curve. If you have more numbers, then that will be restricted to follow that. So in that way, you're going to have, if you have as many number of points on the circumference, you can, the very smooth will be the curve, okay. So I want you to take minimum 12 points. I'll go for taking 4 points here, just 4 points, because it will take time for me to take all the 12, okay. So only 4 points. axis. Okay, it shifted now here and not taken properly. Okay, let it be. So this is the base. I'll just go for taking otherwise 8 points. Okay, some 8 points will draw. So, but I want you to take minimum 12 points. Okay. So all these lines what I am drawing should be very thin. I should get only the points. I need not draw the line, right? Okay. So then this is A, this is B. I should get only the point, equidistance point in the circumference. That's my main aim is. So then don't draw these lines using HB pencil. Okay. If you draw it, let it be very thin. You should not see that in that way. You have to draw this. So anyway, I'll just change this because this curve is not at all matching now. I'll just change this to the view. This is draw this with the axis line. Okay, just draw now. Forget about this. Okay, so this is, and if I project these two, this will say the B, this is C, this is D, this is E, F, G, the center line, right? Okay, and the axis line. This is the axis line, right? Consider this now as the axis, right? And it was inclined. Even then, now also it is not perfect. Okay, anyway, okay. So it says this is O and O1, G, H, dash. Okay, all this with dashes. So anyway, since it says OE is resting on XY line, so we'll go for making that O and E here dash. So then taking this E to A drawn arc, then O to A drawn arc, and we're going to redraw this sketch. Okay. So redraw this sketch. Okay. So let it be O. So this is A, then this is B, the center, C, this is okay, D, E, F, G, H, right? So this is the axis line. So what about the axis line now? It is inclined, okay, with HB. So when you project all these points, okay. Then draw the locus from all the points. See that the base is now nearer to me compared to this vertex. In that case, we're going to have this as A, this is B, this is C, A, B, C, this is D, this is E, this is F, G, and this is H, and this is O, and this is O1, right? So then, since the base is near to the observer, I can see the base completely. They can go for marking this with the tick continuous line, the complete, what do you call, the profile of the base, which looks like an ellipse. So I can draw this something like a plane lamina, inclined now at 7 degrees with HB. I got this ellipse, right? Okay. So then tangential to the outermost curve from this point O to join the line, not to particular point. Okay, don't go to any particular point, just take like this. So tangential to this, not to any G or E like that. Okay, so complete that. So now the axis line, medium thickness. So now they say if the axis is inclined, that's what I said. Cone of 60 mm diameter and the height of 80 mm is resting on one of its end generators on HB, and the axis is inclined at 30 degrees to VP. Always they are going to give you the inclination with VP. In all the cases, in case of prisms, when it is resting on one of its generators or rectangular face. In case of pyramids, when it's resting on triangular face and what I call inclined edge resting on HB. in this case cylinders resting on one of its end generators on HP, resting on in case of cone resting on one of its end generators on HP. The axis will be given only with VP. The axis inclination, if it is given with VP, since the axis is inclined with HP here, the projection of the axis will be apparent. Then you cannot take that inclination what is given in the problem as the same inclination, because that will be the true inclination. Then you have to go for finding beta. Otherwise, if you find something, 3 words what I said, okay, appears to be inclined, so that's nothing but the apparent inclination, then I can go for taking the same length here. I'll mark that. Okay, so if they say appears to be inclined, after that, okay, resting on one of its end generators on HP and appears to be inclined at 30 degrees to VP, instead of just say simply and axis is inclined at 30 degrees to VP, they say the axis appears to be inclined, or the projection of the axis on HP at the top of the axis is inclined at 30 degrees to HP, or plane containing the axis on the generator on which it is resting is inclined. If you find the 3-word sentence, then you can go for directly drawing with the same inclination. If otherwise, if you have only the axis is inclined at 30 degrees to VP, then you have to go for finding beta. So now we'll assume, say if it is given with the 3 sentences, then I can go for redrawing this. So based on again whether the base is near to the opposite word or something like that. Okay, so we're going to redraw this sketch. So redraw the same sketch by again inscribing a rectangle 1, 2, 3, 4, getting all that. Okay, so I want you to redraw that. Okay, I'll not draw this now. Okay, so just redrawing the same sketch which is available here. Same sketch you have to redraw. So then project all this. So anyway, when you project the bases nearer to you, so then you can see this is A and this is say the A. So say this is B, this is C, D say E, this is F, this is H, this is A, B, C, D, E, F, G. So this is G and this is H. Okay, just if I project all that here, this is B. Check out whether the B is near to you, or if it is coinciding also no problem. B. So this is D, this is C, this is F, this is G, and this is H. The same way you're going to project all these points. So in this case, if you want to join the generators, let it be very thin. When you draw this, let it be very thin. So only the view should be visible. Okay, right? Okay, so only the end generator should be a dark line, not this thin lines, right? Okay, so this is okay. So then this is A and A.